Hey everyone, welcome back to our channel Code with AKJ. Today is day 51 of solving Geeks for Geeks problem of the day. And today's problem is minimum repeat to make substring. It's asked in Google, so it's a very important interview question. So let's dive in. So the question says here, given two strings S1 and S2, return a minimum number of times S1 has to be repeated such that S2 is a substring of it. And if S2 can never be a substring, then return -1. So here we need to note that both the string contains only lowercase letters. So let's see input 1. We have given S1 WW and S2 as WW and W. So here we can observe that repeating S1 two times makes S2 a substring of it. And coming to the second example, the S1 is ABCD and S2 is CDA, BCD, AB. And in this case, if we repeat S1 three times, we can observe that S2 becomes a substring of S1. So here we need to return the number of times S1 can be repeated such that S2 becomes a substring of that particular repeated string. So let's begin with our simple brute force approach. So here we'll repeat S1 continuously until the resulted repeated string is at least the length of the string S2. So in our case, we'll take at least the two times of the length of string 2. So after each repetition, we'll check if S2 becomes a substring of that particular repeated S1 or not. So if S2 becomes a substring at any point, we'll return the number of times we repeated S1. And if not, we'll continue with our iteration. After whole iterations, here in our case, we'll take at least two times of the length of the string 2. If still S2 doesn't become a substring, we'll return -1. So let's understand our brute force approach with these two examples. So here I've taken S1 as WW and S2 as WWW. So here let's try to repeat our string S1 at least the two times of our length S2. So here the length of S2 is 3. So 2 times of 3 becomes 6. So we'll try to loop and append this particular S1 at least 6 times. So initially our count would be 1 as we are taking S1 initially. So appending S1 again makes our count from 1 to 2. So here our repeated string would be W, W, W and W. So let's check after this particular appending S1 to itself whether S2 becomes a substring of this repeated string or not. Here we can observe that WWW is present in repeated string, which can be from this index to this index or from this index to this index. So in this case, we can return directly count from this particular iteration as we have found our S2 in our repeated string. So in this case, our output would be 2, which is our count. And let's move on to our next example. Here S1 is ABCD and S2 is CDA, BCD, AB. Here the length of S2 is 8 and we'll try to append this S1 string at least two times of this length S2, which is 16. Count starts from 1. So here initially ABCD and we'll try to append again this S1 to this repeated string RS, which becomes again ABCD. So after this iteration, let's try to check whether S2 becomes a substring of repeated string or not. By observing these two strings, S2 is not a substring of repeated string. So let's try to again append to this S1. So now our counter becomes 3. So after appending it, our repeated string becomes something like this. And here we can observe that S2 becomes a substring of repeated string. So in this way, we have found our string 2 in our repeated string. From this particular iteration, we can return the count of repeated times we have appended S1 to itself. Here, for this particular example, our output is 3. Let's move on to the code and analyze the time complexity and space complexity. So here's the brute force approach code. Here I have taken a repeated S1 string which would be initially empty. Here I have taken the count variable as 0 initially. So I have used a while loop which will run until or unless the repeated string length becomes at least twice the size of string 2. And I'll try to append the string 1 to this repeated string 1 variable. And I'll increase the count variable. And after every appending or concatenation, we'll check whether S2 is now a substring of repeated S1 string or not. So if we found this, we'll return the count, and if not, after finishing our while loop, if we didn't found our S2 in our repeated S1 string, we'll try to return -1 as S2 cannot be a substring within a reasonable repeat count. So let's analyze the time complexity and space complexity of our brute force approach. So here, since we are iterating until or unless the size of the repeated string is becomes the size of string 2, here it takes generally O of m time. And for every iteration, we are trying to check whether S2 becomes a substring of our repeated string RS. It generally takes O of m cross n times. So if we try to combine this, our overall time complexity becomes O of m square n, which is our time complexity. And coming to the space complexity, since repeated string is being added till the size of S1 length, it becomes O of m plus n in worst case scenario. So the overall time complexity of our brute force approach is O of m square n times, and space complexity becomes O of m plus n. As we can see here, the time complexity of our approach is highly inefficient when it comes to the larger size of both string S1 and S2. Here we need to find an optimal approach to reduce our time complexity. So before moving on to our optimal approach, please make sure you like this video, share with your friends and subscribe to this channel. Now let's move on to an optimal approach that leverages a bit more logic to reduce our unnecessary repetition checks. The maximum possible repeats we might need is given by the seal of S2 length by S1 length. And also, to be safe, we should also try one more repeat beyond this, just to make sure that our S2 gets considered and become a substring of repeated string RS. And finally, then we check if S2 is a substring of this repeated string or not. So let's try to code this approach, and later on we'll also analyze the time complexity and space complexity of this optimal approach. So this is the code for the optimal approach we have discussed. Here I have taken the minimum repeats variable, which would be the seal function of both S1 and S2 string length. I have also taken a repeated string which would be initially empty, and I'll try to add this S1 string to itself until or unless it reaches the minimum repeats value. And after adding and creating a repeated string, we'll try to check whether S2 becomes a substring of this particular repeated string or not. If it becomes a substring, then we can return our minimum repeats. If not, we'll again try to add S1 to itself, and again we'll check whether it becomes a substring or not. To this point, if it becomes a substring, we'll return the minimum repeats count plus 1, and if not, we'll directly return minus 1. So let's try to compile and run this. So okay, so let's submit. As you can see, this problem got solved successfully. So let's try to analyze the time complexity and space complexity of this particular approach. So this step takes generally O of m slash n time to calculate the seal function of both S1 and S2 size length, and this find function takes O of m cross n time. So generally the overall time complexity of this whole code would be O of n cross n, where m and n are the size of both string S2 and S1 respectively. And coming to the space complexity, the space complexity remains same, as we are trying to create a repeated string and trying to concatenate S1 string until or unless it reaches at least the size of the string S2. So when we try to compare the time complexity of our optimal approach, here our time complexity becomes m cross n and space complexity remains same as m plus n. So when we try to compare the time complexity of both our brute force approach and optimal approach, we have far more optimized our time complexity from m square n to m cross n, and space complexity remains same, which is O of m plus n. So that's it guys for today's problem. We have covered both a brute force and an optimal approach to solve this minimum repeat to make substring problem. So if you enjoyed this video, please don't forget to like, share and subscribe for more daily coding solutions. Drop a comment if you have any questions or alternative solutions. Thank you and see you in the next video.